On a Saturday night in May 2025, a Mexican Navy tall ship lost control and struck the Brooklyn Bridge, snapping its masts on live television. 2 people died. It was a tragedy, and it could have been far worse. To understand why, you have to go back to 1883, to a bridge that should never have been possible. To build it, workers dug by hand in pressurized chambers on the river floor, spun steel cables no one had ever trusted, and dozens paid with their lives. It became the most famous bridge in the world, and today it's carrying problems its own builders never saw coming, problems that can't be fixed without tearing the bridge apart. That Mexican Navy ship was just a warning. In 1867, New York and Brooklyn operated as 2 separate cities. As many as 50 million passengers rode ferries across the East River every year. During thick fog, the ferries couldn't cross at all, and in winter, the river froze over and stayed impassable for weeks at a time. Building a bridge should have been the obvious answer, but every engineer who studied the crossing ran into problems too big to solve. The East River spans about 1,600 feet at the bridge site, roughly the length of 4 football fields laid end to end. It was also one of the busiest waterways in America, so filling it with pier supports was never an option. The riverbed drops to 44 feet on the Brooklyn side and 78 feet on the Manhattan side. That's deeper than a 7-story building, and on the Manhattan side, engineers hadn't even reached bedrock yet. The US Army also required the bridge to rise high enough for the tallest sailing ships of the era to pass beneath it without lowering their masts. Any one of these obstacles would have stopped a conventional bridge project on its own. A German immigrant engineer named John Roebling said he could solve all of it. He had already built the first successful railway suspension bridge over Niagara Gorge, along with the Cincinnati-Covington Bridge, which held the record as the longest suspension bridge in the world before Brooklyn took the title. His new design would stretch roughly 50% longer than anything he had built before, and it would become the longest suspension bridge in the world when it opened. For the first time in his career, the main cables would use steel wire instead of iron. The federal government formally approved his plan in June of 1869. 3 weeks later, on June 28, Roebling stood on a Brooklyn ferry slip surveying the exact spot where his bridge towers would rise. A docking ferry crushed his foot against the pilings. He refused conventional treatment and poured water over the wound himself. Tetanus set in within days and killed him before workers laid a single stone. Washington Roebling, 32 years old and a Civil War veteran, stepped into his father's role as chief engineer. He inherited the largest construction project in the country and an obstacle his father had never accounted for. The East River ran tidal and salty, packed with layers of silt, clay, and glacial debris built up over thousands of years. To anchor the towers, Washington had to dig through all of it using pneumatic caissons, pressurized underwater wooden chambers lowered to the riverbed so workers could excavate beneath them. By 1883, the Roebling team had solved every one of those problems. What they left behind would stay locked inside the bridge for more than a century. Workers inside the caissons labored at pressures of up to 35 pounds per square inch, roughly what a diver feels 78 feet underwater. They set dynamite in the dark and pulled rubble out by hand. Shifts ran 8 hours for about $2 a day, close to $50 today. When workers rose to the surface too fast, their joints seized and their vision blurred. Doctors had no name for the condition. They prescribed ginger ale and cold showers, and some tried leeches. Between 20 and 30 deaths appear in the official record. Historians believe the real number is closer to 100. Washington Roebling worked alongside his crews and once spent nearly 24 hours underground, fighting a fire in the Brooklyn caisson. In the spring of 1872, after a rapid ascent from the Manhattan caisson, his body gave out completely. At 35, he could barely see. Speaking took enormous effort, and he stayed confined to his home in constant pain for the rest of the project. The person who replaced him at the construction site only got a footnote in most retellings. She deserves the full story. Her name was Emily Warren Roebling, and she was 28 years old in 1872. She lived in a country where women couldn't vote, and she held no formal engineering credentials. For the next 11 years, she became Washington's connection to everything happening at the bridge. Every day she walked from their house in Brooklyn Heights to the construction site. She relayed his technical instructions to the foreman. She defended his design decisions before the Board of Trustees whenever they tried to push him off the project. Emily studied higher mathematics and cable construction on her own time so she could argue the engineering on its own merits. When suspicious trustees demanded that Washington appear in person or lose his position, Emily walked into the board meeting instead and made his case herself. She was convincing enough that the trustees backed down. She did this again and again for more than a decade. On opening day, May 24, 1883, the first carriage to cross the Brooklyn Bridge carried Emily Warren Roebling. Washington watched through a telescope from his bedroom window, unable to attend in person. For over a century, people credited Washington alone with building the bridge, and Emily got a footnote. Today, a small plaque on the bridge acknowledges her, and a street in Brooklyn Heights carries her name. For 11 years, she was the bridge. While the towers rose and the caissons reached bedrock, Roebling's team awarded the cable wire contract to a man named J. Lloyd Hague. Each of the 4 main cables needed over 5,000 individual steel wires, bundled and tensioned into strands, and the entire bridge would hang from them. Hague ran a swap operation out of a warehouse in South Brooklyn. He replaced inspected batches of quality steel with weak, brittle wire that looked identical but couldn't hold the load. By the time Washington Roebling's engineers caught him, an estimated 221 tons of defective steel had already gone into the cables. Once workers spin, bundle, tension and wrap suspension wire, it becomes permanent. There is no pulling it back out. Roebling ordered 150 extra wires added to each cable to make up the difference, and Hague paid for every one of them. That defective wire still remains inside those cables today, and it's only part of the problem. On May 24, 1883, after more than 13 years of construction and $15.5 million in costs, the Brooklyn Bridge opened to the public. More than 150,000 people crossed it on the first day, and President Chester A. Arthur walked its full length. Newspapers across the country called it the 8th wonder of the world. 6 days later, 12 people died in a stampede on the bridge. A woman tripped on a staircase and another screamed. The rumor that the bridge was about to collapse did the rest, and the crowd crushed itself against the iron fences lining the narrow promenade. The bridge suffered no structural damage from any of it. The same 4 main cables the Roeblings designed have held for 143 years. In 2024, New York City finished the most expensive restoration in the bridge's history, budgeting $300 million for the project. Crews cleaned every limestone and granite block on the towers stone by stone, the first full cleaning since the bridge opened. Engineers reinforced the foundations with jet grouting beneath the Manhattan side and rebuilt the approach structures. In July of 2025, the project earned the Diamond Award from the American Council of Engineering Companies of New York, the group's highest honor. Every stone is back to its original grey color for the first time since 1883. The restoration team fixed everything within reach, but they left the cables untouched. Each of the 4 main cables holding the Brooklyn Bridge contains roughly 5,434 steel wires, spun in the late 1870s and early 1880s. Somewhere inside them still remains every ton of Hague's fraudulent wire, exactly where it went in more than 140 years ago. Engineers wedge the cables open at select points along the span and sample the outer wires for corrosion and fractures, and they find both. But inspecting these cables gives engineers only limited data. In-depth assessments of aging New York area suspension cables have repeatedly turned up alarming numbers of broken wires. The way workers bundled and wrapped these cables in the 1880s means engineers can only sample from the outside. Nobody can see what's happening at the center of any cable, and that hasn't changed since the last major internal inspection in the 1980s. Replacing them creates a separate impossibility. Swapping the main cables of a 143-year-old suspension bridge would mean dismantling and rebuilding the entire structure, something nobody has ever attempted on a bridge this old. NYC DOT estimated the full rehabilitation cost for every aspect of the Brooklyn Bridge at over $1 billion back in 2017, and that figure has only grown since. A Wire Rope News essay described the bridge's cables as the world's oldest and largest experiment in metal fatigue. Nobody knows when that experiment will end. The cables are only the first problem though. The second one traces back to a catastrophe 13 months before the Cuauhtémoc collision. On March 26, 2024, the Francis Scott Key Bridge in Baltimore collapsed after a 980-foot container ship named the Dali lost power and drifted into one of its main pier supports. 6 construction workers who were on the bridge were killed. The bridge lacked adequate pier protection for a vessel of that size, and the structure came down within seconds of impact. On March 20, 2025, the National Transportation Safety Board released its findings on that collapse. Investigators identified 68 bridges across 19 states that had never undergone a ship strike vulnerability assessment, and the Brooklyn Bridge appeared on that list. These bridges predate the modern assessment guidelines that took effect in 1991, so regulators had no clear read on their actual risk. NYC DOT said it would review the recommendation and noted that the East River couldn't accommodate a vessel as large as the one that hit the Key Bridge. 58 days later, a ship made that danger real. The ARM Cuauhtémoc, a 297-foot Mexican Navy tall ship carrying 277 crew and cadets, departed Pier 17 around 8:16 p.m. on May 17, 2025, with a sea pilot and a docking pilot both aboard. Its masts stood 158 feet tall. The Brooklyn Bridge clears the river at 127 feet. The ship was 31 feet too tall to pass beneath it. The vessel began backing away from the pier with a tugboat's help, the Charles D. McAllister pushing against her bow. Then something went wrong, and a senior city official later told reporters the ship was moving in the wrong direction, heading toward the bridge when it should have cleared away from it. By roughly 8:24 p.m., all 3 masts struck the underside of the span and snapped as the ship kept moving backward at nearly 6 knots. 2 people were killed and 19 injured by the falling rigging, and cadets stationed high on the masts were left dangling from their harnesses above the water, over a span crowded with onlookers. The NTSB's preliminary report, released June 30, 2025, found a bent rudder turned sideways and pilot commands that had to be translated from English to Spanish before the crew could carry them out. The agency has reached no final conclusion, and a full report could take more than a year. Here's why it could have been far worse. The Cuauhtémoc was tiny next to the container ship that leveled the Key Bridge, and it struck the span, not the towers. The masonry was never in danger from a vessel that size. But a ship had still lost control on the East River and hit the Brooklyn Bridge, 58 days after the NTSB warned that nobody knew how this bridge would survive a strike. The Cuauhtémoc was a warning shot. The real threat is the next ship, and whether it's the size of the one that hit Baltimore. The Brooklyn Bridge piers still lack real protection, with nothing like a fender system or deflection barrier built to absorb a modern ship strike. Workers built the limestone tower foundations back in 1870 for a world where ships measured a fraction of today's size. The Key Bridge collapse showed exactly what happens when a vessel strikes an unprotected pier at speed. NYC DOT has announced no pier protection plan for the Brooklyn Bridge as of mid-2026. The bridge has never looked better, and the questions surrounding it have never been bigger. The Brooklyn Bridge is sound. Every structural inspection confirms that, and engineers expect the recent rehabilitation to keep it functional for decades longer. But the Roebling family solved 3 impossible problems in the 1870s, and the 2 problems affecting the bridge today were never part of that original list. Fraudulent wire from the 1880s remains inside cables that no engineer can fully inspect or ever replace. Tower foundations built for a different century now remain vulnerable to the kind of vessel strike that took down a bridge in Baltimore, and that a ship nearly repeated in New York just 13 months later. The bridge is safe today, but it's carrying fraudulent wire nobody can see and piers nobody has protected. So the real question is, does New York fix this before the next ship, or does it wait for its own Baltimore? Tell us below. And don't forget to subscribe for more Mega Build stories. See you in the next one.